Have you ever wished the things we build could just heal themselves? I know it sounds like something straight out of science fiction, right? Well, today we're diving into the science fact behind materials that can literally bleed to heal.
No, really, just think about it for a minute. What if that tiny crack on your phone screen just vanished on its own? Or what if the little fractures inside a bridge could seal themselves up long before they ever became a real danger? This isn't just about making life more convenient. This is about completely rethinking the stuff our world is made of.
But to really appreciate just how big a deal this dream of self-healing is, we've got to start with the universal problem that every engineer grapples with, the simple, unavoidable fact that everything breaks.
I mean everything. We're talking about the advanced carbon fiber composites in an airplane's wings, the concrete holding up our skyscrapers and bridges. Pretty much all materials are in this constant fight against breaking down. Over time, they get these tiny microcracks. And the scary part is, this damage is usually hidden deep inside where you can't see it, but that's exactly where catastrophic failures begin. It leads to huge maintenance bills and, of course, really serious safety risks.
And how do we fix it now? Well, honestly, our current methods are a lot like putting a little Band-Aid on a broken bone. We just patch up the surface. We almost never get to the real problem, that hidden damage deep inside. We have to find a better way.
So, when engineers need a better way, where do they look? Well, as they so often do, they look to the greatest engineer of all, nature. Think about it. When we get a cut, our body doesn't just slap a patch on it, it heals itself from the inside out.
And taking a page from biology's book, scientists are basically developing three main strategies. You've got intrinsic, where the material's own chemistry can reverse damage. Then there's capsule-based, which uses these tiny embedded bubbles of healing liquid. But the one we're going to focus on today is the one in the middle, the vascular approach.
And the idea here is just beautiful in its simplicity. Just like the veins and arteries that pump blood through our own bodies, a vascular self-healing material has a whole network of tiny hollow channels running through it. And these channels are filled with a healing agent, basically just waiting, ready to rush to the rescue the second any damage happens.
Now, this isn't just one cool option among many. As the research is showing, this whole vascular approach has some serious, game-changing advantages, especially when you start thinking about durability and healing more than once. So look at this. On the left, you've got those capsule-based systems. Once one of those little capsules breaks and releases its juice, that's it. It's spent. It's a one-and-done deal, really only good for tiny cracks. But then you look at the vascular systems on the right. Because that whole network can be hooked up to a reservoir, you can just refill it. That means it can heal over and over and over again, and it can tackle much bigger areas of damage.
And this chart right here really shows you the difference. It's incredible. The microcapsule systems, that's the blue bar, they get one good heal in, and then boom, efficiency plummets. The single networks in red, they last for a few cycles, but then they drop off too. But that interconnected dual network in black, look at that. It survives for 30 healing cycles, all while staying incredibly efficient.
The researchers themselves said it perfectly. These interconnected networks they're in a completely different league. That ability to heal repeatedly is what takes this from a neat idea to a technology that could actually change everything.
Okay, so this all sounds amazing, right? But it brings up a pretty big question. How on earth do you build a tiny, complex network of veins inside a solid block of concrete or carbon fiber? Well, the engineering is just fascinating. So one of the earliest ways they did this is kind of like an ancient technique for making jewelry, called the lost wax process. You start by putting a scaffold, let's say a wire made of a metal that melts really easily inside your main material. Then you let that main material harden all around it. And finally, you just heat the whole thing up. The wire melts, flows right out, and voila! You're left with a perfect, hollow channel exactly where that wire used to be.
For something with a bit more precision, they use techniques like soft lithography. So first, you make a mold that has the exact network pattern you want. Then you fill that mold with something disposable, like gelatin. Once that's all set, you encase the whole thing in the final material you want to use. Then you just melt and flush out the gelatin, and what's left behind is a perfectly printed microscopic network. So cool.
And then you get to the real cutting-edge stuff with methods like VASC. That stands for vaporization of sacrificial components. This is just amazing. They take these special sacrificial fibers and weave them right into a material like carbon fiber. After it's all cured, they apply heat, and the fibers don't just melt, they vaporize. They turn directly into a gas, leaving behind a flawless 3D network with absolutely no messy residue.
All right, so we've looked at the problem, we've seen the inspiration from nature, and we've checked out the mind-blowing engineering that makes it all possible. So, what does it all add up to? What would a future that actually mends itself really look like?
Well, the potential applications are just staggering. I mean, imagine airplane wings that can heal from impact damage while they're still in the air. Think about concrete in our buildings and bridges that is constantly repairing its own internal cracks, making them last for decades longer. Cars, ships, offshore oil platforms, all able to fight back against the constant abuse from their environments.
And look, this isn't just about making things last longer. This is a fundamental shift in how we build our world. It means we'd use way fewer resources because we wouldn't have to replace things so often. It means way lower costs for maintenance, and most importantly, it means a huge leap forward in the safety and the reliability of all the structures we count on every single day.
So I'll just leave you with this to think about. For basically all of human history, we've built things knowing, accepting that they will eventually fall apart. But what if we can finally break that cycle? If our creations can actually endure, regenerate, and last for generations, what new, incredible possibilities will we be able to build then?